Hello and welcome back to Higher Maths Integration. We are looking at differential equations. A differential equation is an equation involving derivatives. For example, dy dx equals x squared. So we're going to look at solving these. Remember, if we differentiate, we might get x squared. So if we integrate, we'll get back to what we started with, 1/3 x cubed plus c. So a solution of a differential equation is an expression for the original function. In this case, y would equal 1/3 x cubed plus c, because if we integrate, if we undo the differentiation, if we undo differentiating, where we end up with dy dx, we'd end up with y equals, and we'd have to integrate the x squared, which would be 1/3 x cubed plus c. So in general, y is the integral of dy dx with respect to x, or f of x equals the integral of f dashed of x dx. Okay, guys, remember integration undoes differentiation. So if I want y and I've got dy dx, I'll just integrate to get back to y. This will result in a general solution since we can choose the value of c. So remember, I've got the constant of integration x. We could be differentiating 1/3 x cubed plus 7, or 1/3 x cubed plus 9, or 1/3 x cubed minus 17, and we'd always get x squared. So when we're solving a differential equation, we will be given a little bit extra information. We will be able to calculate the value of c. So let's have a look at a couple of examples. So question number 1, y equals f of x passes through the point 3, -4. dy dx equals x squared minus 5, express y in terms of x. So I know dy dx, I'm going to integrate that with respect to x to get y. So that'll be x cubed over 3 minus 5x plus c. Now I know this graph passes through the point 3, -4, so when x is 3, y is -4. So I can substitute that into here. So y is -4, x is 3. Evaluate the right-hand side there. I'll end up with -4 equals -6 plus c, so therefore c is 2. So then I can go back to this line over here and replace the c with 2, because I know the value of c is 2. So I will end up with y equals x cubed over 3 minus 5x plus 2. Right, question number 2, guys. I suggest you have a go at doing this one yourself, and then so pause the video, have a go at this one yourself, and then see if you got the question right. So pause it now. Okay, let's have a look at where the answer is coming from. So I've got f dashed of x. I need to integrate that to get f of x. So to do that, first of all, we need to rewrite 1 over x squared as x to the power -2. So integrate all of that and add on our constant of integration. So the one thing I'll just talk about here, we're adding x to the -1 divided by -1. So if we're adding a negative, we're basically just subtracting there. And rewrite x to the -1 as 1 over x before substituting in. Okay, so we are told what we're told. We're told f of 1 equals 4. So when x equals 1, f of x equals 4. So substitute in the values, and we end up with 1/3 minus 1 plus 2/3, which is 0, plus c. So c is 4. Then we can rewrite to find f of x. Okay, so what we're doing the integration like we always have, and we're given a value of x and f of x, or x and y. We're substituting in to find c, then rewriting f of x or y at the end to give a particular solution rather than a general solution, which is the one that involves the constant of integration.